Alright, hello everyone. In this video I'm going to walk you through the process to set up our third lab, which we're going to call the Marble Lab here. So, what you should have open to start is you should have two things. You should have the instructions from this slideshow, and you can find those on our Google Classroom. Click on the link to the slideshow for the third lab. And you'll see this here. You want to go to the third slide, has the instructions here. The other thing that you should have open, which you also can get to through the Google Classroom, is you should have open your lab template here. So find the lab for lab number 3, the Marble Lab, and have that open as well. So what you're going to do here is you're going to use this video and the following slides to make sure you get everything set up for the start of this lab here. So the first thing you can do is, if you look down in green, watch the following video, which is what you're watching right now, and then use the following slides to set up the lab. So that's what the goal of this video is, and your goal should be in the next several minutes here. So the first thing here, our phenomenon that we're looking at is how efficiently can tomatoes pack. So if we have a crate of tomatoes, how does the size of the crate of tomatoes determine how many tomatoes we can fit in there? But unfortunately, for this lab, I don't have hundreds of tomatoes for everyone to use. So we're going to have a different system. We're going to use a model system, something that's similar to a tomato, but something that's much cheaper and not as easily damaged to get our hands on. So for this one, for this lab, what we're going to use is we are going to use little marbles here. So you can see them here, little marbles, and we're going to see how do the marbles pack, because a marble is similar to a tomato. They're both sphere or roughly spherical. So if we can figure out how marbles pack, we could then generalize it to our case of the tomatoes, of how they pack in a crate here. So our research question is going to be, how does the diameter of a circle affect the number of marbles that fit within that circle? Keep in mind the independent variable is the diameter. So we're going to change the diameter of a circle, and then essentially we're going to count how many marbles fit within that circle. So what you have here is you'll go to your lab here. You'll type title of experiment, Marble Lab, we can call it, and then you can put your name here. Whatever your name is. And then we've started labs with a wild guess question before. This lab does not have a wild guess question. It just has the research question. So you're going to put our research question, which is right here on slide 6. You're going to type out that question right here. How does the diameter of a circle affect the number of marbles that fit within the circle? So you'll type that out right here. You can even pause this video right now as you go do that. Alright, so now that you have the research question here, the next thing that you're going to want to do, and if we look at our next slide here, or 2 slides down, I guess, is we're going to come up with our hypothesis. So our hypothesis is based on what we've learned before. What is kind of our guess is what's going to happen. And again, we've done this in 2 other labs before, so this should be relatively familiar with to you. So what you're going to get is this in words right here. I think as the diameter of the circle increases, the number of marbles that will fit in it will, and then you're going to make your prediction. So what do you think will happen here? So that's where you're going to put it right here. In words, you're going to type that out here. Type that out right here. All right. So you can pause the video now and do that. Okay, so now hopefully you should have that written out as well. The next thing that you're going to do is now you're going to make a graphical prediction of what you think will happen here. So what you do is you can hit edit, or you can just double click on it, and this will pop up as well. And now you want to make a guess of what you think your graph is going to look like. For the number of diameter of the circle versus number of marbles that fit in it. Alright, so I'll help people set up the axes here. Keep in mind our diameter is our independent variable. So diameter of circle will go there. And we want to make sure that we keep our units there. we're going to be measuring in centimeters. And then here it's going to be number of marbles. And number of marbles, we're just going to call that unit n for number. Alright, so now what we're going to do is we're going to pick our units here. It's not going to be 100. The biggest circle we're going to measure is 20. So then that would make this 10 here. And now we're going to have to pick our scale for this. Doesn't really matter what you pick your scale to be. If you have a diameter of 20 centimeters, how many marbles do you think are in it? Keep in mind that your marble could be this size, it could be smaller, it could be a little bit bigger. Depends on what group you're in. So right now we're just interested in the general pattern that we're going to predict here. So in this case, maybe I think in 20 centimeters, maybe I think there'll be, I don't know, 80 marbles here. So I'll put 80 there, half of 80 would make this 40. So now I have it set up. If you think 80 is too high or low, you can always change that. Next thing I'll do is now I want to make some data points here. And again, I'm going to make them boxes because that's our uncertainty boxes here. And I'm going to say, well, if the diameter of a circle is 0, I know no marbles are going to fit in it. If I don't have a circle, no marbles can fit in that circle. So I know I can put a 0 there. Now I'm going to say, let's just come up with some sample data. 10 centimeter diameter of a circle. Maybe I'll say, I don't know, I think maybe about 20 marbles fit in it. I'm just kind of getting the general pattern here. Just so we can kind of come up with a prediction. Alright, I'll put a box there, that will be my uncertainty box. And then maybe I'll put, for 15 marbles, maybe what I'll say. Well, if I said it was 20 at 10 marbles, maybe it's, I don't know, right here looks good. Maybe a little bit less than 40, 30 something there. And then I'll add one more data point, so I'll have a nice 3 data points here. And at 20, I thought, oh, maybe it's going to be 80 is going to be there. So that's what my data is going to be. Alright, so I have some nice data points. Now I'm going to make a trend line here and make kind of a prediction of the pattern. I think it seems to me, it seems like as I increase the diameter of the circle, the number of marbles should increase. So now I'm going to add a trend line here. And keep in mind, remember, my trend line is going to try to fit through all of them, all of the data points as closely as possible. This is about as good as I can get for my hypothesis. So generally, my general trend is in this direction. It looks like it's going to be a proportional pattern, is what I predict it's going to be, and it's going to go bigger the circle, more marbles fit in it. Alright, so once I'm happy with that, save and close, and you can see right here, it's saved it. I should have in words there. Alright, so now you can, hopefully if you're following along, you'll be at this point, or you can pause the video now and complete your hypothesis in graph form. Alright, so we have that. The next thing that we're going to get set up here is we're going to get our data table all set up so that when we get in lab, we can collect the data and take our measurements very, very quickly. So if I go back to my slides here, what I have here is I have a slide that has how we set it up. We need to make sure we have all our controls, our qualitative data here, and then diameter of the circle, number of marbles, and then with the units, and then our uncertainty. So that's what we need to get down. Any lab we're doing in the future, you're going to get all of this down. Alright, so if we go back to the lab here, you're going to want to think about the controls. So anything that you think needs to be held constant in this experiment. We're going to be changing the size of the circle here and seeing how many marbles fit in that. So those are the two things we're going to be measuring. But there's lots of other things that could have an impact. So things that we might want to hold constant would be the size of the marble, for example. Marble, we want to make sure that is the same, and then we're going to size the marble, and we'll actually measure how big the marble is. It might be 1/10 of a centimeter, it might be 1/2 a centimeter, it might be 2 centimeters. Again, depends on your group. So size of marble equals, and then you'll fill that in tomorrow when you're with your group, or maybe later today if your group gets that far. So the size of the marble is going to be one thing that you want to keep constant, and then think about anything else that you might want to keep constant. You might want to make sure they're all spheres. Anything else, I'll let you pause here, see if you can think of anything that needs to also be held constant as well. All right. So if you want to take a look here, the next slide I've given you some ideas for the controls. Marble width 1 centimeter. For example, yours might be more or less depending on your group. The marble mass is something you want to keep constant too, because you wouldn't want to be changing your mass. Maybe that would have some sort of effect. And then the other thing is you want to use all the same type of marbles. So this one they're making it from glass. Ours are going to be, they're actually ball bearings, so they're made from steel here. So you could have them all made from the same material. And then qualitative data, some things just to keep in mind about it. Marbles aren't perfect spheres, so our ball bearings are pretty good, and that's why we're not using glass marbles anymore, but they still might not be perfect spheres, so if they're not perfect spheres, maybe they don't pack together quite as well. And then maybe the Petri dishes walls don't go high enough, so it's difficult to know if exactly a marble fits in. You'll see that sometimes it's kind of hard to tell if one marble can fit in or if it's sitting on top of the other ones. So that's something to keep in mind. So make sure you have the qualitative data down as well here. And then it shows us what we have here as well. So what we're going to do here is our independent variable is going to be diameter of the circle, and we need to make sure we have our units, which is going to be in centimeters, and then our uncertainty here, when we've done some measuring before, we've had it been plus or minus 0.3 of a centimeter. I think the slide says 0.5. Either way works, but we really want to make sure we're getting as accurate as possible and that all of our measurements for the diameter aren't more than plus or minus 0.3, because that's the uncertainty that we're shooting for. And then here, this is going to be our average, and the dependent variable is number of marbles. And our units, again, are just n, because it's the number of marbles. N stands for number. And then our uncertainty here is going to be plus or minus, and it's going to be plus or minus 1, because when we have all the marbles in the circle, it's going to be hard to tell, does that last marble fit in, or can we not fit any more marbles in? Or maybe we could saw one in half and get half a marble in, based on how much space we have left. So our uncertainty is going to be plus or minus 1 here. So we'll have that. And then again, your trials are going to be, for this diameter of circle, you'll fill up the marbles in that circle, count how many they are, then you'll probably get someone else in your group to do another count to double check, and then you'll get a third person in your group to double check, and hopefully you should all agree that that's the same number of marbles in each of these circumstances. All right. So with that said, if you're at this point now, what you can do, and if you look at the next slide here, is stop here, wait for the rest of the class, and then when you are done, you can, if you are done and your partner's not, quietly help them with this so we can get everyone to the same spot. All right, see you back in the real world.